Hello, Maurieo! Land Survey 1. Traversing Assignment Briefing. Welcome to this video where I'll be running through or providing a brief on the traversing assignment that I have. So I'm going to first of all try and find the traversing assignment, and then we'll see if where we can go from there. So here it is. This is the Bachelor of Engineering Technology assignment, which is the same assignment as for the NZDE, but it's just a little bit has a little bit more in it, and I'll point out the extra bits as we go along. So here we go. First of all, that it's due in on Monday the 22nd of May in 2017. Now that may vary year on year, but that's when it's due. Now each student will produce a unique assignment report, but they'll collect the data as a group or a team together, the teams that they've been in or that you've been in for the whole year. And you must include your original field notes and other data, regardless of what you transition those field notes into. We always keep the original so that we can always refer back to the original record. And it should follow the usual field note protocols with regards to rubbing out and erasing and those sort of things. The documentation is to be emailed to the tutor in a digital PDF format, single document, no later than 11:59:59 on the due date above. We've got the usual the 3 learning outcomes, which are fairly consistent for this course. For the Bachelor of Engineering Technology, this is worth 9% of the course mark, and for the NZDE, I think it's around 15%. So the marking schedules have been just adjusted accordingly. So what we're trying to do is just to undertake and record survey measurements of a closed traverse, to reduce, close and adjust the measurements and present them in a format to meet client requirements for a specific purpose. A lot of students ask me, is this suitable, is this okay, will this do, and that sort of thing. And my sort of response over the years to them has evolved over time, and essentially what I say to them is that this survey that we're doing here is probably best part of a couple of days work, as it turns out, for a field party. Probably would be around, maybe could have an all-up cost of around about $2,000 or $3,000 for what we produce. I'll say to them, what you're handing to me, would you pay $2,000 or $3,000 for that? And that should answer the question that you're presenting this. This is the product that you're presenting to the client, and how it looks reflects on your company and your work and the credibility of you and things like that. So it should be top of the line stuff that's being produced. Okay, so let's have a look at the task. So you've gone around and leveled this area, so you do have some leveling data, and that is to be incorporated into this assignment here. So one follows on from the other, and we're going to do the development in the park, and it includes the removal of the existing topsoil stockpile. So you need to place 2 additional traverse marks to form a closed traverse, with 2 existing marks and a 3rd existing mark as a check bearing origin, or as to help prove origin, the 3 marks. The traverse mark should be situated free from disturbance, and I have put some traverse marks out there and concreted in that students can use, or you may use a peg of your own for the new marks, but you must come off at least 3 of the existing marks with bearings and distances between them, and you can use the marks that I've provided, or you could put your own peg in if you wish. One of the big problems in this is we're working in a fairly confined area, and so we need to keep out of the way of other field parties. At worst case scenario, we have 5 field parties operating, and that can get quite congested, particularly if they're using the same mark. So we need to be wary of that. We're also going to check that the dimensions of the existing boundaries and some of the other existing marks, we need to verify them and just check that they're all good and they haven't moved, and that we can continue to use them for work. We're also going to have to produce or find or measure the stockpile and collect some topographical data there, sufficient so that we can use that data to determine the volume of the stockpile. Now for the BTEC, we will go ahead and determine the volume of the stockpile. For the NZDE, we'll just collect the data, and we won't be going any further with volumes and things like that. So we want the field information collected on suitable sheets. Generally, I would recommend 1 sheet per mark. So each mark you go to, you set up and use 1 sheet for that. I've provided ample sheets. As part of your report, you'll need the original field notes, bearing closures, traverse closures, boundary calculations, stockpile volume, height closures, which I possibly haven't included in there, and they should be recorded on suitable formats, and maybe even reports out of software. You might like to include video and photographs if you can, and if you're unsure about a proposal or how you're going to do it, talk to your tutor. Your report should have a format that will be easily followed and understood by your client and meet their requirements and their expectations with regards to costs. It's essential that you communicate with your tutor to clarify what's required, and that would almost be on a daily basis. That's a real important factor of most surveys, is that you keep up to date with the client. Things change fairly quickly in a construction environment, and they may need more information or less information. So it's important that you keep talking to them and keep where you can. Original field notes or copies of the originals must be submitted with your report. So pretty straightforward, really. So here's the marking schedule. You'll see that the first part of the marking schedule is practical, 4.5 out of the 9 for that, or half of that. And a lot of these are things that are on your practical task sheets or things that you have ticked off already. So you do need to be wary of these. Make sure that you tick all the boxes, so to speak, with these as you go. So you've got this here, you've set up a total station over a mark, got it all signed, sort of make sure you've reduced height distances, independently checked a couple of distance measurements. So you might want to think about how you're going to do that and how you're going to show it, how you're going to collect the evidence. It's all about the evidence, collecting the evidence. If you've got evidence that you have drawn field diagrams, well, I can sign it off. If you've got evidence that you have independently checked a distance measurement, I can sign it off. And there's 4.5 marks there just for coming to class and doing the practical tasks and taking the time to get them signed up and collecting appropriate evidence. Similarly with the report, there's a whole lot of targets to hit there. They're not that difficult, and you might need to talk to me about getting them right, but you can work through those fairly methodically. Health and safety, bearing coordinates and height datums for the 3 sort of measurement systems that will be in place, accuracy standards, traverse sheets, topographical data, volume of the stockpile is calculated, information presented clearly and accurately on plans or diagrams. Now the volume calculation is not part of the NZDE, so there will be a different marking schedule, there. So you just need to keep an eye on it. I hope that I have, I think I've got that all right there. Just see that 0.45 in there, but I think that might be correct. I may have to adjust a couple of things there, possibly. I think that was initially 0.5, so that seems all good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 times 225. 10 times 225 is 225. 6. So yeah, it's probably about right. We'll have a look, see how we go. So I may have to adjust that somehow along the line, but you'll be kept up to date with that. And then, of course, there's the team scoring sheet, which you'll be familiar with the last one, where you score the other members in your team. If you don't put a sheet in yourself, you don't get any marks. So make sure you get that done. Here's the job instruction, and it's pretty much covers pretty much the same material. Existing control traverses are basic. Put in 2 new marks using 2 existing marks in the loop, plus an extra mark for controlling the bearing. Position of the 2 leveling pegs. Some other control points that are there. That's if you can. If you can't measure to them, that's it's all right. Don't worry. But if you can, do, and just be able to do some calculations to check them out that they haven't moved, and it just checks out that your methods that you're using to measure are pretty good. Existing boundaries as well need to be checked. There's little nails and tops of the posts, and we have little small prisms that you can use that make things pretty good for that. So yeah, calculation sheet, sets of plans and calculations. And as I said, your report should be value for money. So if you need to put in, as I said, when you're thinking about your report, would you be prepared to spend $2,000 to $3,000 for that report of that quality? And if the answer is no, well, you need to go back to your drawing board or your living rooms or kitchens or wherever it is you put these reports together, and get it up to a standard that you'd be prepared to pay that amount of money for. Now, here's our plans here, and I thought what I might do is just go to town a little bit here with the line tool, and draw a few bits and pieces of line on this here, just to give some ideas as to what's going on. So I'm just going to probably just change the color here to red, and I'll make my line a little bit smaller, maybe 5 points. Okay, so typically you need a starting point. Now we can't see down through here because we've got the survey sheet in this one here. So you could say, for instance, start here, and that would possibly, you might not want to use, that would be your check origin there, and then you could put another line down here. So you might want to say come off those two marks there. So you'd possibly set up at NL and use this line down here, set this line here, set the bearing. Now 283 is going up over here, so you want to take 180 off that. 103.0220. So you'd set 103.0220 down that line if you were set up here at NL, and then you'd measure that and hope that you got 122.54, which would indicate that these two hadn't moved. You would set that bearing there, and then turn around and check this bearing here, which looks like it's 333, 4340, and check the distance as well. So that would be your origin. And then you might say, right, I want to do a traverse. So you'd go from there to there, and then you might, just using some of these existing marks here, you might go to IB, BJ there, and like that. So that might be your leg, and then you need one. So that would become a new mark. IBJ there would become one mark, and then you might put another go from there to say this mark here. That could be then that would form another leg. It's very important that you remember which mark you use. That was a problem that we had last year, as people put pegs quite close together. You can put a peg in of your own. This is on the ridge down here, and then obviously then you would close the traverse off like that. So you'd close your traverse off. Okay, like so. Now, as I said, we've got three main marks. So that would be our traverse. Now, from this peg here, you would check these radiations, 1, 2, 3, 4, remeasure those and check, and as long as you got fairly close to those values there, you just accept the old values. Same here, you accept the old values as long as you've got quite close. So with this mark here, you could check all those boundaries. You can't see down to there from there anymore. So what you might do is there. So well, let's start here. So you could check all those boundary lines there, and you probably can't see into that corner particularly well at all now, but because of there's a shed in here. So then you'd come down to here. You could check those boundaries in there. While you're here, you may as well check this line here down to here. You could check that just to make sure that that's all good. So that would put a line down in there. You could check that, and you might want to check that post in there as well, because you won't be sitting up there. You could come down to here and possibly check this corner here, check it out, or just take a measurement to it, and then we'll come back into the office and calculate these boundary bearings and distances to make sure that those things are all good. You've got IBMM over there. You may be able to, with a bit of luck, you might be able to see these here from here, from there into there, from there into there, okay, and from there into there. You do need to make sure that you can get all the measurements you want from around the stockpile. So getting some around the back of the stockpile might be a wee bit tricky. So you may need to sort of come over to here and use marks over here that you can get your stockpile done in and around here. So I'll just put a bit of a circle. Oh, there's it's an ovally circle, so put that. Oops, put that in there like that, just to represent the stockpile in there. So remember that you'll need to do shots all around that. So that's the idea of your traverse. Picking up from here, you might just want to get this main mark here, like get that in from there as well. So these are radiations. These ones here form part of a closed network, so they are the most accurate measurements. Then you've got your radiations, which are quite accurate as they're going to a point, and then you've got your various topo shots, which are real small bickies, and they're just to little marks on the ground around here. So yeah, you just around there. So that gives you 3 different sort of orders of accuracy for the marks. But that's the idea with the traverse. That's the sort of thing that you'll be doing, closing it off and collecting all that information. Oh, don't forget the 2 pegs on top of the. Oh yes, you've got 2 pegs on top of the on top of the mountain, so they'll be, oops, yeah, so you'll get 2 pegs up there, and possibly another one there. Okay, so they can be traversed in up there as well from various marks. Probably, you might have to do something around there to try and sort out any problems in the back there, but as you can see, you can hook onto those from there, various locations, and yeah, and then we can measure and calculate between them. So that's the idea of the traverse. There's the boundary, so that's the original control plan. There's your boundary bearings and distances. There's a bit of a photograph of it. These are all available as part of the thing. This is the team skill scoring sheet. So that's the information that you're given. Alrighty, and then what you've got to try and do, what does success look like? So we've got to try and turn it into something that looks like this. So this is a report from last year. There's the stockpile there. As it was last year, a large portion of it has been moved in the middle of the project, I might add. So made life a little bit difficult for those trying to determine the volume of the stockpile. But nonetheless, we managed to get through, as we always do. Okay, so here's our report with our scope. Origin of bearings and heights is that could be done better than here. There's an origin of bearings, there's an origin of coordinates, there's an origin of heights. Each of them has a datum, and each of them has an origin of an origin point with values, and each one of those needs to be addressed. Methodology, what equipment you did, sort of a bit of a workflow about how the job did, how you recorded the data and got it back into line. Now you can see here accuracy. Probably a bit more work needs to be done in the accuracy area. This bearing closures have been recorded here. You'll become familiar with those. So you got a 19-second misclose, 4 stations. It's around about 4 or 5 seconds per station, which is pretty good. Here's the actual traverse here. So they had HC to NL, that was available last year, and they've now built a shed in the way, and then they checked back to MM, and then they put in 1, 2, 3 new pegs like that in around there to form their loop traverse. A nice little diagram there, just for clarity. And there's the traverse closure, 9 mils and 12 mils. The height closure based on the heights that they did using the total station. We've also got the heights from the levelling, which can be incorporated. Health and safety. A traverse spreadsheet was done using 12D, which is survey software, and that was also used to check out boundary bearings and distances, make sure everything's right. And that little report is just printed straight out of 12D. The topographical spreadsheet was for putting data into the just into an Excel spreadsheet and putting the data into 12D so that we could calculate out some volume. We got 2,000 cubes. What was there last year? Drawing a little plan. So here's the plan with it's got some bearings and distances and things, and you can see the radiations out to the marks. Some bit of detail around the actual stockpile itself there, and yeah, posts and marks and things like that, all on a plan. Very tidy. And then this is the data that we collected for the software, just sort of the data that we collected for the stockpile, sort of once around the top and once around the bottom, like so, was sufficient for us to be able to calculate it. So here's the actual stockpile getting smaller and smaller, and so we included that with a little bit of a photo in there, and then some conclusions, and then all the data. So here's our field notes here. Every field note has a diagram associated with it, which we'll talk about that in the course of the work, and these all need to be numbered up and what have you. So there's second page, 1 mark per page, and just the diagram sort of drawn with north and approximate bearings and distances there. We ran out of field notes here by the look of it, so all sort of working away, but all of the information is put there into the mix. And here we have our field book diagrams. Field book should be all labelled up with page numbers and things. Perhaps not totally done here, so needed some more work on that. Still going, and these are our topo shots there, and then a bit of a diagram of the whole thing. Perhaps another peg's been put in there or something like that. But various. Showing where pegs are and various things. Hazard IDs. So this is all in the survey report. There's the survey report. Hazard management, hazard ID, each one for each day. And then most importantly, the practical task sheets, because they're how I sign up various things. Set up total station, booking, reduce observations. It's all signed up, so it's just marks are pretty much there. That little exercise that we did just the other day for that, Trevor sheets, practical tasks, so 8. Put them all in as all part of it. They're all signed off, ready to go for you to get your marks without too much trouble. So there we go. That's what we've got. I think as far as a briefing for the Trevors, that's pretty much it. So now it just means just need to get on with it, get the Traverse going and get started on it, and get a mighty fine Traverse out of there, and a nice report that looks like a couple of grand, looks like a couple of $1,000 worth. So work away on it, try and get things work in your teams, collecting the data and helping one another. But ultimately, each person must put out a report of their own that is credible, and and I will mark it. So that brings us to the end of the briefing. Cheers. See you.